Hey everyone, welcome to the Data Science Interview Question Series. In this series, we will be looking at a wide variety of questions related to data science, machine learning, and deep learning. These are the questions which are asked in most of the good product and service-based companies. These questions test candidates both deep mathematical understanding of algorithms and how the algorithms can be implemented to solve the real-world problems. Typically, interviewers starts with some very basic question about an algorithm and then they keep digging into different aspects of the same algorithm. So we'll also try to follow the same flow where I might ask you to define a simple algorithm, say logistic regression, and then ask a follow-up around the same. So without wasting any further time, let's get started. So let's start off by defining the logistic regression. So intuitively, logistic regression simply tries to find a hyperplane which separates two classes, and it uses cross entropy as the loss function to separate for the training purpose. Now let's move on to the interesting follow-up. So here's the follow-up. What will be the consequence of using mean squared error instead of binary cross entropy with logistic regression? So in general, binary cross entropy is standard loss function with logistic regression. But try to think what can be the consequence if you use mean squared error instead of binary cross entropy. Pause the video and try to think for the solution. Okay. Before we move on to the solution, I would like you to hit the subscribe button and press the bell icon so that you never miss an update regarding an interesting interview question. Let's refresh the formulas and notations. GT represents ground truth, pred represents predicted value. From here on, I will be calling binary cross entropy as BCE and mean squared error as MSE. So let's plug in the value for ground truth as 1 in binary cross entropy. So we get minus of log prediction. Now let's do this same for the ground truth as 0. So we get minus of log 1 minus prediction. So in both the cases, the final output we get is a function of log. So it would be interesting to see how the graph of log actually looks like. So this is how the graph of log looks like. Since the value of logistic regression can never be greater than 1, so we are sure that the prediction value will always stay smaller than 1. And so the range which we'll be interested in is going to be the range of x between 0 and 1. And it's interesting to see as the value of x decreases to 0, how the value of y actually tends to minus infinity. This property will come handy as we go in the further slides. So let's try to see some mathematical analysis on the prediction values. We will be looking at two cases. First one when the predictions are close to ground truth. Second one when the predictions are far from the ground truth. So let's see when the predictions are actually close to ground truth. The MSE and BC value comes out to be 0.01 and 0.045 respectively. And this looks good since the predictions and the ground truth are closer. So the loss values are smaller in magnitude. So the magnitude of loss should be lower since the predictions are good. Now let's see when the predictions are far from the ground truth. In this case, we get the MSE and BC respectively 0.81 and 1. So this is much bigger in magnitude, and this seems to be fair enough since the ground truth and the prediction value are much farther from each other. So the error value should be much higher. So when comparing the close ground truth with close value and ground truth with far values, this seems like a fair comparison. And again, the magnitude of loss should be higher because when the predictions are bad. Let's say your model starts to give crazy predictions during training, which is 0.0001. In this case, the MEC value is going to be close to 1, but the binary cross entropy is going to be much higher than 1, which is 4. Let's say after a while it gets even crazier predictions, which is 0.000001. In this case, the MSC value is again going to be closer to 1, but the BC keeps increasing. Why is this happening? Let's try to look at the graph and try to understand why is this happening. As you can see that as the value of x shrinks to 0, the value of y goes to negative infinity. That is the reason why BC keeps increasing as the value of x getting close to 0. while the MAC stays same no matter what. The MAC cannot be greater than 1. Let's summarize all the points. Remember guys, this is how you will be speaking to the interviewer. So in short, the binary cross entropy penalizes the wrong predictions more abruptly than the MAC, while the MAC loss cannot be more than 1 even when the model predictions are completely wrong. So it cannot update the weight more aggressively in case of crazy predictions. Therefore, the final classifier is not going to be very powerful if the MAC is used as a loss function instead of binary cross entropy. If you find this video helpful, please consider subscribing. Who knows, this might be the next question in your next interview. Also, if you have any suggestions for other topics, please let me know in the comment section, and I'll see you in the next video.